Hey guys, how's it going? So, Mark and I put together this presentation, Structural Shoring with Access Scaffolding, primarily because we've been getting a lot of calls and questions from our clients regarding these types of projects. Specifically when talking about structural engineering or structural shoring, a lot of times people think of very heavy-duty loads and pre-manufactured shoring frames that are designed specifically for these types of projects. However, about 95% of the projects that we work on are actually done with access scaffold systems. And so the primary point of this presentation is to essentially run through the various types of projects that we do on a daily basis in structural shoring in which we use access scaffold systems, just so we can give you guys a general understanding of the marketplace that's out there. And hopefully you guys can learn something and know what projects to go after, or you can bid and gain more confidence in using the systems that you guys already have stocked in your yard. The second goal is to run through some various checkpoints or checklist items that come up on every single structural shoring project, and go over some common issues that arise day in and day out on these types of projects. Again, our goal is to expand the knowledge of the access scaffold industry for this marketplace, so hopefully you guys can go out and gain more confidence and win more projects of this type. Where's the clicker? So the main difference between access scaffold systems and structural shoring systems is really just the factors of safety. So typically, as you guys know, access scaffold systems need to be designed to a 4-factor safety. However, most structural shoring applications only need a 2.5. So this allows us to bump up the allowable leg loads for a lot of our systems. So we're actually capable of supporting more load when using our same equipment in access scaffold applications. For example, a typical 3-foot wide access scaffold frame and a 4-legged tower configuration can support loads ranging from 12 to 20,000 pounds. In comparison, modular scaffolds, depending on the manufacturer, can support loads ranging from 20 to 60,000 pounds. When looking at a standard heavy-duty shoring frame, those guys are actually good for about 40 to 50,000 pounds. And so a lot of times, using our modular scaffold systems, they're actually stronger and more versatile because you guys have different ledger lengths and even cross-bracing lengths handy in your guys' yards, and you don't need to outsource them. What's the laser pointer? So just looking at the left picture, this is typically what we have encountered our clients think of when they think of heavy-duty shoring. However, more often than not, we have to pick up roofs or floors, and we're actually capable of using our standard modular or access scaffold frames. And again, we just want to run through some various items. So if you guys have any questions, we'll be here at the end and we can talk about if you guys have encountered any issues when bidding these types of projects. And so we're going to run through some shoring checklist. There's 4 key points that come up on a large majority of projects. And really just the goal of this is to outline different areas to be aware of in the bid phase so that you don't run into issues as you start the project or get later on the project when it becomes a time crunch.
Right, so as Mitch mentioned, there's 4 key components that, if taken into account at the beginning of a project, can just help things go much more smoother. It helps you estimate it more accurately, and it just prevents any sort of surprises once the project actually gets going. The first one's going to be the structure and structure capacity. Anytime a new project comes up, the first question we're going to ask is, what's going on? Why do you need shoring? Are they pulling out columns? Are they pulling out walls? Things like that. That'll help you focus in on what exactly needs to be done to the building so you can get an idea of what kind of shoring you need to come up with. This is also a good time to have a conversation with your client about who is going to be answering any questions on that structure if they come up. Do they have an engineer in the background who's going to be able to step in and start answering questions, or are they going to turn to you and expect you to answer that question? This can be planned for, but it's better to get that out up front versus when the shoring's already in place and the guys are just about to start demoing. The second one's going to be equipment availability. This is just taking a look at what's in your yard and what you guys want to show up to the project with. Do you have modular scaffolding? Do you have frames? Do you have steel beams, or do you want to use aluminum beams? This is where you put it all on the table and pick and choose kind of what you want to use. This is the part where typical scaffolding actually has a really big advantage over heavy-duty shoring, because you guys have the equipment, it's available, you're familiar with it, and you can get to the site with it really quickly versus trying to re-rent heavy-duty equipment that your guys don't know and that it's just really hard to move around. The next one's going to be equipment design. Once you know what equipment you want to use, just double check and make sure it's going to be strong enough. Make sure you have enough beams, the beams can handle the load of the span, making sure that your posts are going to be strong enough, or if you need to spread load out over possibly multiple towers. The last one's going to be the layout. This is where you want to have a really clear conversation with your client and making sure you understand what kind of phasing they're going to be going through the project, and asking if they have any clearances that they require. Because once you get your shoring system in place, moving it is a pain. So making sure you guys are both on the same page from the outset can really make it go much more smoothly.
And so throughout this presentation, we're going to run through a couple case studies, and this is really just to go over some specific projects in which access scaffold systems were used as a structural shoring application, and really just outline the versatility of these systems and how they were actually crucial to the success of the project. So first case study is a Wakefield project. So imagine getting a call, late afternoon on a Friday. There's just been an earthquake, and we have a 7-story concrete structure that has had 2 of its columns sheared and are actually only being held in place by rebar. And so we went out to do an emergency site visit just to find a lot of the workers jackhammering out these foundations right below these columns. And so it became incredibly crucial to get a shoring system in place so these guys could safely finish their project. However, because this was kind of a last-minute emergency thing, it needed to be done quickly, and there really wasn't time to go out and outsource a pre-manufactured shoring system, and there definitely wasn't time to go through and design like a custom fabricated steel shoring system. So what we had available was a ton of modular scaffold posts. And so what we ended up doing was throwing as much equipment as possible at it. There were 7 levels of concrete, which is incredibly heavy. But because we were able to space these posts very tight together, we were actually able to transfer all the load away from the columns into our shoring system and down into the slab on grade. And so this allowed the workers to cut off the columns at the base and install new columns. Essentially, what there is to take away from this project is, even if you guys run across a project where there's really heavy-duty loads, a lot of times if the equipment's available, we can throw enough at it to get the job to work. And it's just a great situation of where you guys have an advantage with all the equipment that you have in your yard. You're able to get out to these job sites incredibly fast. So we're going to run through several types of structural shoring in this next section. It's really just to outline the common jobs that we do on a day in and day out basis. Some of you may be aware of this, some of you may not, but we're really just hoping to expand you guys' knowledge on what types of jobs you can go after with your standard access scaffold equipment.
So yeah, the next few slides are just going to be some typical types of shoring when you go out on site and you might see. It's not going to be an exhaustive list by any means, but it'll give you kind of a good idea. Those types are going to be the slab and beam support shoring, needle beam, or also known as wall shoring, truss shoring, shoring for equipment and vehicle loads, and then miscellaneous types of shoring. So the first one is beam and slab support. This is going to be your bread and butter type of shoring. This happens day in, day out, all the time. Basically, anytime you're going to cut a floor or a beam away from its supports, it's going to need a little help. So that could be like slab cutouts, or like a column removal, or the removal of a load-bearing wall. Typically for a wall removal, where you have a long run of floor that's going to be cut loose. Shoring is going to be kind of a linear run of scaffold underneath that free-floating edge, versus like a beam support kind of shoring is going to be an individual tower underneath. For majority of these kinds of shoring projects, the loads are ranging right around 30,000 pounds, which is right in the sweet spot for typical modular or frame scaffolding. So these kind of projects are right in your wheelhouse.
So next type of shoring is needle beam shoring. This comes up a lot. It's really whenever you have an existing CMU wall, reinforced concrete wall, timber stud wall, that's having a hole cut in it, and the wall above it is going to stay in place. And so key items to look out for on this one is really just the clearance and how far away from the wall you guys need to be in order for the general contractor, your guys' client, to get the job done. We understand that a lot of times you guys don't stock the needle beams or steel beams in your yard, or if you do, you have a specific type. So this is just a good example of where, reaching out to your local engineer, telling them the general dimensions of the wall, what the parameters are, and they should be able to size these beams relatively quick for you guys in the bid phasing process. Other items to be aware of are like the opening of the wall, or the new opening size. A lot of times, depending on the height of the wall above the opening, you may not actually need shoring to support that wall. And it's just good to reach out to your engineer, because this could go a long way with your guys' contractors, especially if you're saving them money on shoring, and it'll make them want to come back to you for the future project.
So truss shoring is going to be really similar to your typical beam shoring, but you're going to want to pay attention to a couple of things, because trusses are a special case. Due to their space frame design, there's not a whole lot of material in between the top and bottom chords. So if it's not supported in a certain way, you actually could damage the truss. A couple of ways to prevent that is going to be, first of all, I'm going to borrow that from you real quick. You're going to want to support the truss at the nodes. So the nodes are going to be where the web elements meet the chords. This is going to be the strongest point on the truss. So that's going to be where you want your initial support beams. In certain cases, depending on the span and the loads, you may still need to block between the top and the bottom chord. This will give the web a little extra boost and prevent you from essentially crushing the truss. The last thing you want to keep an eye on is the cantilever spans. Depending on where you put your shoring tower, you're going to start moving in on your truss, and trusses are specifically engineered to span and be loaded a certain way. That's why they're so economical. But if you start moving too far away from how it was originally designed to be supported, you could actually reverse the way it's being loaded and damage it. This picture is a project that shows a good example of truss shoring, where a worker had accidentally backed a forklift into the column. And so what happened was the shoring contractor got a call, and he was able to come out with typical scaffolding really quickly and set up shoring to make the building structurally sound, but also leave room so they can come in after the fact and replace the damaged column.
So the next common type of structural shoring project that we encounter a lot is equipment and vehicle shoring. There's really two types of this specific structural shoring application. One is when there is a new building going in place. In order to erect it, some heavy pieces of equipment need to drive on existing elevated slabs. The second option is when there's a gap in between an existing location that we need to get to and the access point for that piece of equipment. And this is actually an area where you guys really have a huge advantage, because the only other option the contractor really has is to come up with a prefabricated, steel or concrete system that can actually bridge the span. However, you guys a lot of times can come in and build the scaffold up from the ground to provide these solid decks across these areas that they need to bridge. And even if there is really heavy-duty loads, a lot of times you guys can get the design accomplished with either tighter post spacing or special deck beams. Really, this is just a good opportunity, or types of projects for you guys to go after. The other option is when there is an elevated slab, a lot of times there's some type of crane or heavy object that needs to drive along a certain path of travel. So key components there are figuring out what is this path of travel, how many elevated slabs above the slab on grade are we, and how far down we need to shore. And again, a lot of times you can coordinate with your engineer and come up with different designs and post spacing that are going to meet the requirements of these equipments.
So miscellaneous shoring is basically any sort of temporary shoring that's not really a structure or a building. Usually it takes the form of equipment that's being supported during repair or during installation. Because a lot of this stuff is not really a building, it's proprietary equipment, things like that. The first thing you're really wanting to do is talk with your client and get just a good idea of what kind of weight they're asking you to support. Then you'll be able to kind of figure out what kind of equipment you want to use and what the configuration of your tower is going to be. Like in this example of miscellaneous shoring, we were able to design a scaffold tower using typical equipment to support the approximately 50,000 pounds that were going to come from that extended arm. And we also worked closely with the client on how they were going to de-stress the supporting cables at the top to make sure when that arm came down, it was in a controlled manner and it evenly loaded the tower.
So we're going to run through a couple regulations and requirements. Really, this is just to outline various codes or requirements when you guys are actually going and bidding structural shoring, just so you guys have an understanding of what to look out for as it relates to OSHA and various items.
So when it comes to structural shoring scaffolding versus access scaffolding, there are actually very few requirements and regulations that you're being really held to, but there are a couple that you're really going to want to keep an eye on. The first one, when it comes to OSHA, is knowing your base to height ratio. In the majority of the US, it's going to be a 4-to-1 base to height ratio. In California, that's increased to 3-to-1. So that's just to make sure that your scaffold has a good foundation of stability for supporting whatever you're asking it to. One important distinction you're going to want to make, though, is whether it's a freestanding scaffold or it's going to be a tied-in scaffold. For example, this shoring scaffold supporting the pipe is a freestanding scaffold. It's all by itself. And so you're really going to want to make sure you at least meet that 4-to-1. So when they start flying in the material and dropping it down on your scaffold, there's no chance of wiggle room. Compare that to this example, where the shoring is essentially doing the same thing. It's supporting a pipe, but the pipe is now fully installed, it's fully tied in. And so in this case, there's less chance of it running away from you. So you aren't being held as strictly to the OSHA requirements. But if you have any sort of questions or you're not really sure about it, I highly suggest that you call an engineer and just talk it out. When it comes to the strength of scaffold, it's going to be the SSFI requirements that you're going to keep an eye on. Those are going to be the factors of safety of what your components are designed to. For scaffold frames and modular posts, it's going to be a 2.5 factor of safety. For beams, it's 2. And then for individual post shores, it's going to be a 3. But as Mitch started off with, the important thing is just knowing the intent of your scaffold. Because if it's going to be designed for shoring and you're not expecting it to be like a work platform, that is what lets you start reducing the required factor of safety from the OSHA 4 to the 2.5.
And so this is our second case study, and again, we're really just doing this to outline the versatility of access scaffold systems under structural shoring applications. So this specific project was in Pasadena, California. We had a 2-story concrete parking structure that was going to have a new shear wall installed. However, the foundation of this shear wall was so large that it was actually undermining all of the adjacent columns. And so what we had to do was come up with a shoring design that was able to support the loads from the adjacent columns, but get the load far enough away so that the new excavation and foundation could be installed. And key items in this project were the low vertical clearance in the basement level of the concrete parking structure, as well as multiple contractors needed to utilize this shoring system. So essentially, we needed to come up with a shoring system that would mold to the various requirements of the different contractors. And so the final solution was actually to pour some smaller foundations of the larger foundation and span the loads out to those locations. However, due to the large beams that were required, we had about, I think, 200,000 pounds per tower that needed to be supported. There was only about 3 feet of clearance left between the beams. And so as you guys know, most pre-manufactured shoring frames are usually a minimum of 4 feet tall. So what we ended up using was a mixture of modular scaffold systems and pre-manufactured posts. And for this contractor, he had these posts available, so lucky it was already in his inventory. But because of this versatility of these types of systems, we were actually able to fit all of the shoring in between the sill beams and transfer the load adequately. And this is just a good example of where the versatility of your guys' systems actually go above and beyond that of the pre-manufactured systems. And if it wasn't for this type of system, we wouldn't have been able to accomplish this job. And so this next section, we're going to run through common shoring issues. And these are essentially just items that come up on every single project. And the reason why we're running through them is so you guys can be aware and preempt them and talk to your client about it so that we don't run into these issues halfway down the line or in the middle of the project.
So the first one is going to be excavations adjacent to your shoring tower. A really common reason why you're going to need to install shoring is installation of a new foundation. However, if a contractor comes in and starts digging a hole right next to your tower, then there's a very real risk that he's going to undermine it, you're going to start losing soil, and you're going to lose the foundation that you just built your scaffold off of. So having a good idea of what's going to be going on around during the project and what your scaffold is sitting on is pretty important, like whether your scaffold is going to be sitting on a slab on grade, and if so, how thick is it? If it's not and you're sitting on dirt, is it well-compacted dirt, or is it really loose and you're going to need to start looking into a bearing pad, things like that. In addition, all these things put together are going to determine how far away from the edge of any excavation you're going to need to be to maintain the solid foundation of your scaffold. As you can see in this example, if we need to start playing with how close you are to an excavation, it's going to start increasing the span of the shoring beam. That could turn into requiring a bigger beam. And it also could start increasing the loading, which is going to trickle all the way through that shoring system. And now you're playing catch up after the fact. So getting that information nailed down ahead of time can just make everything go much more smoothly.
So other common shoring issues are multi-floor loads. And this really occurs when you have a support system that supports multiple floors and the shoring needs to be installed to pick up each adjacent level. And items to look out for on these types of projects is, especially in the bid phase, know that most of that load is going to accumulate into the lower couple floors, and you're probably going to have to throw more equipment in those areas. As you get up to higher floor levels, the shoring typically can be thinned out, but just being aware of this up front, and especially when you're putting bids together, making sure that you guys have accounted for the right number of pieces. Other items to look out for with multi-floor loads is which side of the post the load is coming in from. So in this case, most of the load is coming in on the right post. So as you get down to the lower levels, it's really just one line of post that's supporting the majority of the load. And so depending on how heavy the loads are, you guys might want to account for outriggers or some type of support for this inside leg as you go down. Other items that are typically very critical for multi-floor loads are sill beams. A lot of times these structures aren't designed to transfer the loads through these slabs. They're meant to go directly into the columns. So more often than not, especially when you're bidding, you're probably going to have to account for sill beams to adequately spread that load as you transfer it to the lower levels.
So oftentimes, the orientation of what you're supporting is just as important as where you're going to support it. Asymmetrical architecture and odd distribution of loads can quickly magnify the amount of weight you're asking your shoring systems to support. For example, if you are supporting a second floor beam, but there's a third floor above and it has a column that comes smack down the middle of that beam you're supporting, you just probably double the amount of load that you're going to have to pick up. Another example is this project where we put together a shoring system to support the 3rd and 4th floors of a building so they could demo out the 3rd floor column. But during the initial planning phase, the scope changed, and it turns out that they're not only going to demolish the 3rd floor column, but also the base of the 4th floor column. So what that did is it turned our 4th floor shoring into not only supporting the tributary width of that 4th floor beam it was picking up, but also supporting that 4 foot by 4 foot column that weighed approximately 30,000 pounds just hanging off the end of that beam. So that turned our approximately 100,000 pound load into like a 250,000 pound load instantly. So once we knew about that, we were able to accommodate and redesign the shoring system. But as Mitch mentioned, that trickled all the way down on the multi-floor loads. And if that had been installed first and then they changed that second, it would have been a complete nightmare to try to redesign the thing.
So the next common shoring issue is uneven loading. And this actually comes up quite a bit. And the reason why this is so important for you guys is because when you guys are provided with manufactured data for your post, more often than not, it's based on a 4-legged tower that was evenly loaded. And for example, they give you 4,000 pounds with a 4-factor of safety for a typical modular scaffold post. This assumes that it's in a 4-legged tower configuration. However, as what occurred here in this picture, there was a pipe in the way up top, and so the contractor was forced to shift the top support beams over the front 2 legs. And so not only does this increase the load to the front 2 legs, notice that both of them buckled in the same direction without engaging the back 2 legs. And so the actual design load it buckled under was less than that the manufacturer had published. So just being aware of where the towers are going to be and if there's any field obstructions up front, and if something does force you guys to shift the support beams, do your best to install the tower as centered as possible. In some cases, if the loads are light, it's not going to be that big of a deal. However, definitely want to reach out to your engineer to make sure you let him know, hey, we're out in the field, something was in the way, so we had to shift the tower and the beams. Just a critical item, this typically comes up during the actual installation of the project. And so just being upfront with your client, and so everyone's on the same page with what needs to be done.
Yeah, so we'd like to say it goes without saying that driving things into your scaffold while supporting a building is a bad idea, but we get enough phone calls that as a public service announcement, we'd like to say it's a bad idea to drive things into the scaffold. Honestly, this really just kind of comes down to talking with your client and just being really clear of what kind of activity is going around your shoring and taking to any accommodations that might help them not hit your stuff. This could be as simple as incorporating a drive lane or something into the shoring so they can get through it, because a simple conversation can not only give them life safety, but it also just limits your liability out on site, because you can't be there and you can't babysit it all the time. So it's going to be a conversation you need to have.
So existing structure checks. The reason why this is important to you guys is it really comes down to understanding who's taking responsibility for the structure. As a scaffold contractor or installer, typically you guys want to be responsible for your system that you install and make sure that it's strong enough to support the loads it was designed to support. However, determining whether or not the structure can be picked up at that specific location definitely should be discussed up front with your contractor, your client. More often than not, there's a structural engineer of record on the project who's designing the retrofit or is more familiar with the existing structure that can actually take the shoring design and look at the structure and make sure it's adequate to be supported at that location. And the reason why you definitely want to have this conversation is if they do want to put it back on you, a lot of times it's a lot more expensive and time-consuming to check the structure versus actually produce a structural shoring design. So being able to account for that time and additional cost is very important up front, because if it comes up in the middle of the project, a lot of times there's fingers pointing on who's responsible for taking this cost. Other items are minimizing deflection. A good example of this is if someone's chopping off a column and you install your shoring towers and the system shifts 1/4 of an inch. If there was a prefabricated column that was cut to fit, they got to figure out how they're going to lift that system up a 1/4 inch before they're going to put that column back in. So it's just very important to talk to your client, see if there's any deflection limitations or requirements for the project up front, so they're not trying to figure it out after the fact.
So the last one we're going to touch on is public access. So the majority of shoring projects are going to occur on a closed construction site. You're not going to get a lot of pedestrian walking through or anything like that. But on the odd chance that you are shoring a structure and it could be open to the public, you're going to want to talk to your client and clarify whether that's something you need to take into account or not. Because once it's open to the public, it kicks you into a whole new world of regulations and restrictions. It's going to make you design for the building code, which includes any sort of permanent loading requirements that come with it. Also, it's going to kick you into municipal review. You're going to have to put together stamped plans, possibly pull permits. We're talking submittal to cities or counties, things like that that are really going to mess with your timeline and drag things out before you can even get on site and start building. Also, in the more extreme cases, you're going to have to design for lateral loads, either wind loading or seismic loading, regardless of how long it's going to be in place. They're going to want to see that thing completely locked down. All these things can be taken into account after the fact, or I'm sorry, you want to take these into account before, because trying to retrofit after the fact is just an absolute nightmare. So hopefully this presentation helped kind of show you guys some of the shoring that you can go after and just kind of broaden your horizons on what kind of projects are applicable with the kind of equipment you guys already have.
Any questions? Correct. They were. Yeah, so typically the 3-foot wide, 6'4" walk-through frames or 6'8" walk-through frames can support loads from 12 to 20,000 pounds. In that case, it was just a couple steel beams and a timber roof, so the loads were very light. In that case, the general contractor called and said our scaffold system had failed, but when they went out and checked it out, there was a bunch of dents in the side of the system. It was obvious something had ran into it. Yeah, I mean, we have a lot of data on different manufacturers' load ratings, plus we have the tube sizing, so we can always run standard steel checks as well.
Back when you were talking about shoring existing structures, you mentioned deflection.
Yes.
Do you give specific installation instructions about preloading?
Not typically, unless it's in the project specifications. A lot of times, if the deflection is large, I'll talk to the client about that and make sure that they talk to the general contractor, and then we'll note it on the drawings for the engineer to double check and make sure that's okay. But unless there's something specific on the drawings, we typically don't, outline stuff like that.
In my experience, if you're talking about placing concrete, there's no load there, basically. So when you're putting your shoring in, there's really no preload. But on existing structures, I've always given specific instructions that they need to preload the legs so that we don't get settlement and deflection, just for things like trying to put a column.
Yeah, I mean, it could be very difficult for the contractor, though, unless they have a load cell to figure out how much they're preloading their scaffold system just by beating the screw jacks. So a lot of times we'll just say install tight, and this is the deflection, and then we'll account for it after the fact. If that's going to be an issue, then specifically we'll have a load cell on the project. But more often than not, in a large majority of our cases, we don't need to do that.
Mm-hmm. So usually when we do a design and we check through the components, we'll design to minimize deflection as much as possible, so you don't have that problem. So you can just install it tight and you'll pretty much be good to go. If the spans on the beams, for example, start getting larger and there is going to be some significant deflection that you might have to take into account, that's where we're going to stop and talk to you about it and see how do you want to proceed. We can either upsize the beam, take that out of the equation, or yeah, exactly, put together something for you.
Yes?
A lot of times on existing structures, we have engineer records that always cost us finding your
You don't say.
Yes, when it's required, we will do that. We obviously prefer as-built drawings. Well, first in line, we prefer that the engineer of record takes responsibility for his structure. But if that's not the case, we'll go to as-built drawings. And if those aren't good enough, hopefully we can resort to you guys being out there, FaceTiming, taking pictures, and then last resort is we'll go out and check it out ourselves.
I've been involved in jobs where sometimes the engineer of record, let's just say, has not done their due diligence. And shows the shoring on truss and beam. You have the roof trusses resting on beam. And they're going to remove like a couple bays.
Mm-hmm.
And the engineer didn't notice that there were some non-moment carrying splices.
Mm-hmm.
So when the beams were cut, he didn't request shoring in the correct location. Luckily, they lost some roof bays, but it happened after hours. It was like it was a ballasted roof, so a whole section of roof was collapsed on top.
Yeah, I mean, that's an unfortunate situation, but a lot of times, hopefully, with us reviewing the plans, with the engineer of record reviewing, and someone catches it, in some situations that does happen. Ideally, though, when we put together design, we will look and see if there's anything specifying a splice. The worst case situation is where there is no splices specified. So, if you guys are out in the field and you notice something, it's always good to just get back in contact with us, because we don't always see everything either.
There's a lot of buildings that you're not going to be drawn on. So really, the engineer should be out taking a look at. I really think that the shoring contractor can be the last line of defense and notice something before they start doing the demolition.
No, agree. We're all on the same team, right? So the goal is to get the job done safely. So we all should be doing our due diligence.
Yeah, absolutely. I mean, you guys know what you're doing. You're the ones on site. You guys can get eyes on it. So if you see something that doesn't feel right, yeah, throw up a flag.
I think one of the big things that we found we had to convey, especially when we're working with you guys, is what actually they're going to be doing. And I know the demo contractors, and there's Bobcat going nuts up there.
Yeah.
And it's like all of a sudden we're coming out and stuck in the lead towers because there's a rolling load that we didn't anticipate, so they decided to change the process that they're on. And like that, but I think that information is probably critical not only to us, but to you guys.
Yeah, I mean, up front, you guys have different clients. We have different clients. If there's a contractor out there that has done something like that in the past, and just being upfront and open with them and to us. And sometimes if you want us to design it for more because you feel that that's not the case, we'll outline different items. But just knowing your clients and just being as open as possible and making sure that they understand the limitations of the shoring. But again, it's not a perfect world. Stuff like that happens. Luckily, there is some factors of safety in what we design, but it's very important for everyone to be on the same page.
I mean, coming back around, things change on site. Guy gets behind, and he just starts blowing walls out and things like that. And the nice thing is, modular scaffold is really versatile. So yeah, you originally designed to support this one beam, and then you blew out those 4 columns. Well, you can get out there, you can install some new shoring, and look really good, save the day. You can have those conversations and try to get it all out in front, but yeah, things happen, so.
One of the things that I come across a lot is when you're doing the truss shoring and they're trying to remove an exterior wall, they want 8 feet of clearance.
Mm-hmm.
Crazy like that. So you're saying like you can't get any closer to the wall.
Yeah.
Because they
Mm-hmm.
want to drive a full-size forklift. You're trying to get as close to the end of the truss as possible.
Yeah, with that, there's been times where we'll talk about having one side close and then the inside maybe 8 feet off to at least limit that. It does become an issue when you have 8 feet on the interior and exterior. You start getting 16-foot spans, you start getting really big beams, especially if the wall is tall. But
I'm talking about where there is nothing on the other side, but they just want to get rid of that wall. So
Like an exterior wall demo? Yep.
so they want to hang the wall from the truss. So,
they basically want, now they're going to take the wall out, but they want you to support the roof,
got it.
but you're way
So cantilevers can be okay if there's a large backspan, right? If you have 8 foot of cantilever and you got 50 foot of back truss, it's probably going to be okay if you're picking it up at a panel point like Mark was saying. But if you got 8 feet of cantilever, 8 feet of backspan, or something small, then it could be an issue. And that just needs to be talked about up front. There is limitations as well.
You also look at exterior wall demolition that you could allow with the tie down cables to prevent uplift on the roofs on your exterior shoring.
Yeah. So for example, it's good to understand how much of the exterior wall is being removed if, for example, I worked on a Target project where it's all tilt-up wall panels. There's cases where they're just taking 20 feet out of a 300-foot wall. It's not going to be that big of a deal. But if, in one case, they took all 200 feet out, so we had to run cables in every single bay to prevent uplift, and we also had to provide lateral support in the case of wind loading. We didn't design for earthquake loading, but we had to essentially replace the shear wall with cables. And it's just important to have that conversation up front. Sometimes you don't really need it, but if you're going to be going into the windy season, it's definitely a good conversation to have. Any other questions? Well, thanks, guys. We appreciate it.